Hey guys, all right, so now we're on to the cube root functions, which has the same exact process as the square root functions. We're going to graph and describe transformations of the cube root function y equals the cube root of x. We're going to identify key features of the graph that models a relationship between two quantities. So same exact things that we did for the square root function, we're now doing with the cubed root function. So it says the function r of x equals the cubed root of 3 over 4 pi x. It represents the length of the radius of a sphere as a function of its volume, represented here by x. An approximation of this function is r of x equals the cube root of 0.24x. The radius function is a transformation of the parent cube root function f of x equals the cubed root of x. So this is our parent. So the parent of the square root was f of x equals the square root of x. The parent of a cubed root is f of x equals the cubed root of x. Okay. The very most basic format is the parent function, pretty much. Okay, so write r of x as a product in the form r of x equals a times the cubed root of x. We're not going to write it in an exponent form. To the 1/3 power, that's the same thing as a cubed root. So anytime, like if it were a 1/2, it would be a square root. So 1/3 is a cubed root, that type of thing. But we're not going to write it like that. We're just going to keep it in radical form, because it's so totally radical, dude. And it says to round a to 1 decimal place. Okay. All right, so let's do this. So they want us to rewrite r of x, and they want us to separate the 0.24 from the x. So cubed root of 0.24 times the cube root of x. And then we just need to enter this part into our calculator and round to 1 decimal place. So I have my calculator right here. So to get to the cubed root, it's this button right here where the up arrow button is that my thumb is on. We need to hit the second button and get there. But I need to tell it that it's a cubed root. So I have to hit 3, second, and then that button. And then you see it? It has a little X there. The 3 is the X. That's what I'm telling it to be. And then 0.24. And I get this. So I need to round it to 1 decimal place, so 0.6. So this is 0.6 cubed root of x. Okay. Letter B, it says graph r of x and f of x on the same axes. Okay, let's start with that. So let's start with the parent function. Let's start with f of x. We'll put it on the left of the graph. Okay. And we need x and y's. And what's nice about a cubed root is we can plug in negative numbers. You know how in a square root we couldn't because it would make them imaginary? It's not the same thing with a cubed root because a negative times a negative times a negative is negative. Okay, so and a positive times positive is positive. So we can do both. So I want to be strategic and pick numbers to plug in for x that are perfect cubes. So -8 is a perfect cube. -2 times -2 times -2. -1 is a perfect cube. You can always plug in a 0. And now let's go on the positive side. Let's be symmetric. 1 and 8. So negatives, 0, and the positives. All right. The cubed root of -8 is -2. The cubed root of -1 is -1. Cubed root of 0 is 0. Cubed root of 1 is 1. And cubed root of 8 is 2. All right, so when I graph this, I have -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. Looks like it's curving this way, curving that way. All right, so it looks like a squished S. Pulled and squished, pretty much. Okay, this is the parent function. Okay, so this is the parent cubed root function. All right, let's graph r of x now. So r of x equals 0.6 times the cubed root of x. So we're still going to plug in the same x values, the -8, -1, 0, 1, and 8. And we'll get these same y values, but now we have to multiply them by 0.6. So basically all I have to do is multiply all of these by 0.6 because of this 0.6 factor in the front. So -2 times 0.6 is -1.2. -1 times 0.6 is -0.6. If I plug in a 0, 0 times anything is 0. If I plug in a 1, it'll be 0.6 times 1, which is 0.6. If I plug in an 8, it'll be 0.6 times 2, which should be the positive version when we plugged in the negative, so 1.2. Okay, so -8, -1.2 is approximately right there. -1, -0.6 is approximately right there. 0, 0. 1, 0.6 is about right here. And 8, 1.2 is approximately right there. So this is a little shallower. It's not quite as tall as the parent function. Well, what does that mean? Well, how do these graphs compare to each other? Well, the pink one is shorter than the blue one. So that means that that 0.6 out front must have shrunk it. Okay, so we can say that r of x, let me zoom in a little bit for you guys. R of x is a vertical shrink of f of x. And it says, how would the graphs of h of x equals x cubed and j of x equals 0.6 x cubed compare? Well, these are not cube root functions, they're cubic functions. So they're the vertical s thing that we dealt with last unit, but it's the same thing. This would still be a vertical shrink. Anytime you're multiplying by a number smaller than 1, it shrinks it. Anytime you multiply by a number bigger than 1, it stretches it. Okay, so it would do the same exact thing because this is the parent function of the cubic. See, vertex form applies to everything. All right, what are the domain and range of f of x and of r of x? Write your answers as inequalities in set notation and in interval notation. So we're going to do all the notations. I'm going to color code them. So we'll start with as an inequality. So domain and range. So as an inequality, the domain is the x values. Well, these arrows on the blue and the pink mean that they're going to infinity in both directions. So they both actually have the same domain. So how do we write that as an inequality? We say negative infinity is less than x is less than positive infinity. Or you could also say all reals. That funky looking capital R says all real numbers. That's the same thing as negative infinity to positive infinity, all real numbers. So that is inequality notation. In set notation, that's where we use the brackets. So parentheses, because you can't ever equal infinity. So negative infinity to positive infinity. Or sorry, that's interval notation. I guess I'll put set notation last. So set notation is with the squiggly line brackets. So x such that x is in the real number system. So this basically means x can be any real number. Okay. So if you didn't know this before, when you do two lines and then you do your capital R, this symbol represents the real numbers. okay? All right, so that's how I did it. Pink, red, and green. All right, so for the range, well, the range is the y's. Well, because of those arrows, even though they're close to the x-axis, they are going slightly up and out and down and out as they go to infinity. So they're also going to be all real numbers. I'm going to put all real numbers, so that's way shorter than putting negative infinity to positive infinity. And in interval notation, negative infinity, positive infinity. And in set notation, same thing, except we're talking about the range, so y, such that y is any real number. That little funky e just means that y is in the real number system. Okay? So both f of x and r of x have the same domain and range. So both f of x and r of x have same d and r. And that's because they weren't shifted anywhere. The only thing that's different between the two is the vertical shrink by a factor of 0.6. That's the only difference. The pink one is a little smaller. It was squished. It was shrunk. Okay, but that's the only thing. That's the only thing that's different. Otherwise, they still have the same shape. They're still in the same location. None of that changed. Okay, letter D. It says, describe the transformations of h of x equals x cubed. This is a cubic now, that result in the following functions. So remember, x cubed, we did last unit, looks like this. So x cubed looks like this. The cubed root looks like that. Well, but flipped. So they have a very similar shape, except one's horizontal, one's vertical. Okay. But remember how I said that they're going to still perform the same way as far as the transformations go? So j of x equals negative 2x quantity cubed. So that means that we have a negative out front. And I want to separate this. Let's separate the negative 2. And it's cubed. And the x is cubed. So this equals negative 2 to the third power is negative 8. Okay. So that negative means that there's a reflection. And the negative 8 means that it has a vertical stretch because that number is bigger than 1. Okay. So we can say it has a reflection across the x-axis. And a vertical stretch by a factor of 8. We don't need to say negative 8 because the negative has to do with the reflection. So that's what the negative does. The number, though, is what does a vertical stretch or shrink. In this case, because it's bigger than 1, it's a vertical stretch. All right, double I says k of x equals x minus 5 quantity cubed. Well, that minus 5 means that we have a shift to the right 5. So this one is going to have a horizontal, because that's what it means to move left or right, horizontal shift right 5 units. That was easy, huh? Triple I, m of x equals x cubed minus 4. Well, this minus 4 is not in parentheses with the x being cubed, so this means this is a vertical shift. And since it's negative, that means it's down 4 units. Aren't these so easy? They're so easy. All right. Number IV, or Roman numeral 4, n of x equals 2 times the quantity 0.5x plus 4 quantity cubed minus 6. Okay, so this one is tricky. We've got a number in front of the x, and then we have a number out front in the parentheses. So if I were to draw out that 0.5, what would that be? So basically 2 times 0.5. Sorry, I misspoke. I had to pause and regroup because this one's tricky. I keep forgetting it's to the third power. So if I were to take out that 0.5, technically that 0.5 is to the third power. Well, what is 0.5 to the third power? Handy dandy calculator time. Is 0.125. Well, there's that 2 that's out front of it. So what's 2 times 0.125? So I already have it in my calculator. I just have to times it by 2, and I get 0.25. So technically, that number out front is a 0.25. So since it's smaller than 1, that is a vertical shrink. Okay. All right, and then we also have a shift to the left 4 and a shift down 6. So we have a vertical shrink by a factor of 0.25, a shift left 4 units, and down 6 units. Alrighty then. Turn the page. All right, on the back side, page 111, says, how does the graph of g of x equals the cubed root of negative x plus 1 plus 3 compare to the graph of the parent function? Okay, so we need to fix this. There's a negative in front of that x. Let me zoom in. So we need to fix it. So here's the fix. Just like we did on the first page for one of those examples, this is g of x, we need to draw out that negative. So when I do that, I will have the cubed root of, basically factor out a negative from negative x plus 1. So negative x divided by negative 1 is positive x. Positive 1 divided by negative 1 is a negative 1. So if you were to multiply that back in, you would still get negative x plus 1. And then plus 3. Okay. All right. So now let's separate the negative 1 times x minus 1. So remember, this is a cubed root, so we could separate that negative 1 out in the cubed root times the cube root of x minus 1. And then there's that plus 3 still there. Okay. What's the cubed root of negative 1? Well, the cubed root of negative 1 is negative 1. So it's negative 1 times the cubed root of x minus 1 plus 3. So we fixed it, and now we can see exactly what the transformations are. That negative 1 out front means that we have a reflection. The minus 1 under the radical means we're going to the right 1 unit, and then the plus 3 means that we're going up 3 units. Okay. And then it says, how would the graphs of h of x equals x cubed and j of x equals negative x plus 1 cubed plus 3 compare? Well, these are cubics, so that's the only difference, but we can still do the same type of thing. So it would have the same exact transformations. Okay, so let's say g of x is a reflection across, and it's not across the x-axis. The reason why it's not is because this was a shift up 3. So this graph, 1, 2, 3, it was shifted up here. Now it's being reflected, so instead of being an S that way, it's that way. I'm like, how do I flip it in my brain? So it's going to be up there. So it's reflecting across this imaginary line, and that's a y value of 3. So it's reflecting across y equals 3. So it is a reflection across y equals 3. Shift right 1 unit. And up 3 units. And we can say j of x and h of x would have the same transformations. I'm just going to put trans, because I don't want to write out the whole word. Okay. All right, number 3, sketch g of x and f of x from item 2 on the same axes below. Okay, so I'll let f of x be this green color. So that's the parent function. So we know we have a point at 0, 0, 1, 1, and 8, 2, negative 1, negative 1, negative 8, negative 2. That makes the squished S. So there's f of x. Isn't it so much nicer when you don't have to do a table anymore? You just know it. And then g of x, it was, do the shifting first. It went to the right 1 and up 3. So the middle point is there. But it's reflected across this imaginary line. So it's going the other way. Notice these 3 points. They're going to become your best friend because they're always going to be around the center point. So I'm going to start by, do I have a pencil? No, I don't. I'll just use this pink. So if they were right here, but then I reflect them, if I reflect this one across the line, it'll be down here. And if I reflect this one across the line, it'll be up here. So, and then I can fake it till I make it on the rest of them. And there is g of x. Okay. And what are the domain and range of each function? Well, they're going to infinity left and right, which means they're going to infinity up and down for both. So both are, what do you think I'm going to say? All real numbers. All right, we're going to do the check your understanding number 5. It says, why is the domain of a cube root function all real numbers, while the domain of a square root function is restricted to only non-negative numbers? So the reason is, and I'll put the reason over here, we can take cube roots, apostrophe S, of negative numbers, comma, but we can't take square roots of negative numbers since they are what kind of numbers? Imaginary. Imagination. I don't know why SpongeBob always comes up, but yeah, here he does. It's just what I remember students last year saying anytime I said imaginary numbers. Oh, I miss being in the class with my students. I need to get to know you guys and come up with our own little quirks and stuff. Anyways, number 8. It says to describe the transformations of f of x equals the cube root of x and h of x equals x cubed that result in the functions listed below. So we have g of x equals negative cube root of x minus 3, and j of x equals negative x minus 3 quantity cubed? Well, we have a negative out front, so that means a reflection. Same with this one. And then that minus 3 underneath the radical and inside the parentheses means that we are going to shift to the right 3 units. Same thing here. So even though these are different functions, the transformations are exactly the same. What about p of x and q of x? All right, oh, there's that negative out front again, so we're going to have to factor out that -1, and the cubed root of -1 is -1, so -1 times 4 will make that a -4. Just doing that all in our heads because we can, and I think you guys can handle it. Okay, and then same thing here, but if we factor out that -4, we have to cube it, and -4 cubed is -64, and then multiply that by 0.25, and you get -16. So q of x would equal a -16 x cubed minus 1. So when you do that, it makes it very clear what the transformations are going to be. So first of all, we have the negative out front, so that means a reflection. It's a really good Christina Aguilera song. Okay, and it's across y equals -1 because this one is shifted down 1. And we have a negative out front here also, so there's another reflection. Again, across y equals -1 because it was shifted down 1. And speaking of shifted down 1, let's identify that. So this is a shift down 1 unit. Shift down 1 unit, and that's it. Oh, one more thing, I almost forgot. There's a number out front. So can I squeeze an arrow in there? Yeah, this one has a 4. 4 is bigger than 1, so that means it's a vertical stretch. Vertical stretch by a factor of 4. So I'm just going to put by 4 because I can't fit a factor of in there because I don't have enough room. And then this one is a 16. So it's bigger than 1. So this one is also a vertical stretch. And I'll put by 4 because I don't want to write it all out. By a factor of 4. Without graphing, state the domain and range of the functions in item 8. Well, if it's a cube root function, even though it's negative, that means it's going in the opposite direction, versus a cubic versus a cube root. We know that the cube root has a domain and range that's all real numbers, and the cubic has a domain and range that's all real numbers. So the domain and range of the functions in item 8 is all real numbers. So no matter where it is shifted, up, down, left, right, vertical stretch, vertical shrink, reflection, it doesn't matter. Cubics and cube roots will always have a domain and range that is all real numbers. You like my hand gestures? There's a lot more hand gestures going behind the scenes over here. You just don't see it. All right, and that's it. Have a good one.